Good evening, everybody. So let us start our class. So we were discussing threading and multi-threading, right? We're discussing multi-threading programming. So far in our first class, you got an idea that a thread is a program's execution path. An application or a program can have multiple execution paths so that you can parallelly consecutively run multiple modules of an application. That is called multi-threading or multi-tasking program. So the Windows operating system and most of the operating systems are now multi-tasking operating systems. So a multitasking operating system or a multi-threading application will allow you to run multiple or different modules concurrently. In that case, the processor and memory will be shared by the different modules. So by this way, we can execute programs or applications faster. Okay. So we discussed that how to create a thread. In Java, there are two ways to create a thread. Okay, so first one is extending the thread class, and second one by implementing the runnable interface. Right, so the extending thread class is easy. Easiest way to create a thread. That is my thread name I want to create, and then I extend the thread class, and whatever codes or tasks I want to execute are put in the run method. So this is the format of creating a thread. By using this format, you can have multiple threads with different names. And then in your main method, you will just use this thread in order to create a thread, and you will execute the run method by calling the start method. Okay. Although you can call the run method directly, but by convention it is called through the start method, and start method starts the processing program, thread processing, and it's called the run method. This is pretty straightforward, and there is another way to create a thread by implementing the runnable interface. This is a little bit tricky, trickier than complex than the previous method. So the first part is very similar. So we will implement the runnable interface, and then we will put our codes within the run method. And here the problem is the difference is here. So we will call this my thread to create a thread object, but we cannot use this thread object directly in order to call the start method. Here what we need to create another thread object, and within that thread object, while creating that thread object, we will pass the previous thread object as an argument to the constructor of thread class. Then now you will be able to call the thread class. The thread will indirectly call the my thread object. That's the way. And if you understand this part in Java, so that is the starting point for C# people. In C# programs work pretty like this way, similar to this way. Okay, so then where did we leave last class? So maybe we discussed the thread lifecycle last time, right? The thread has 5 different states in its life cycle. When we create a thread, it's called newborn thread. A newborn thread is not ready yet to run. We know that we call a thread by calling the start method. Okay, so when you have a newborn thread, we can call it by using the start method. Okay, then it goes to the active thread level. There are two phases in active thread level: runnable or running. Running means that it's currently running, and so an active thread you can consider that this is a queue of some threads. Okay, so if a thread is running, then you can call the yield method to send it back to the line of this queue. So while running a thread, you can call the yield method to send it back to the running queue, so that it will pause its running and it will go at the end of this line. And when a thread is active but not running, that is called runnable. So when a thread is in this inactive state, we can suspend the thread until another event happens, or until another thread starts, or we can stop it for a certain more time. This is called sleep method, by calling sleep method. It will be waiting until few seconds or milliseconds, or as you need it. So that is, at that position, the thread will be called block state. Block means either suspended, mostly suspended. Sleep actually is after a few times it will be starting, but you can say either sleep or suspended, and you can resume a block state by calling resume methods. Okay, so start method, yield method, suspended, sleep, and resume method we have got so far. And there is another stop method, that at any point you can kill a thread. That means you can destroy a thread if that is no longer needed, if you think. Okay, but one thing, that if a thread is in active or block state level, then it can be resumed to the as an active thread. But if you send it, if you use stop method, and if you kill it, that means it's destroyed. You cannot revert it. Okay. So far, anybody has any question? Anybody has any question? Okay, that's good. So in order to control the thread, there are some methods, built-in methods. Most of these methods are in thread class. In both Java and C# thread class, these methods are used in order to control the threads. It's called thread management process, in order to manage threads. So far you are familiar with some of the threads, like thread start method, run method, sleep method, yield method, join method. Maybe today we will see some methods. Okay, that is what we live. Yes. In last class, yes.
With the Java effects, I think you use like start or run. Is it in any way related to these thread control methods?
So check that maybe you have in your Java effects, if it use multi-threads. If it, I'll show you in a program. If it inherits the thread class somehow, then it will have access to those methods. One thing that maybe I can show you quickly, for instance, remember that when you create any, even let us go back in the very first program. Remember that what is our very first program, what very entry-level programs, that is single-threaded program. even without anything, so maybe inheritance or class, so vehicle main. So in this program, you see that we have created some object over here, right? Vehicle object, right? So when you say vehicle object, you say, okay, there is also this run method is not the run method of thread. Okay, don't confused. So you say v4 dot my computer is slow. Come on, baby. Oh, sorry, it's lowercase v. Okay, v4 dot. You see that there are some methods here, notify wall. These are the two methods. Actually, these methods are mainly used for multi-threading, thread management. Okay, so we will see that the use of these methods, notify and notify wall of uses of these methods. Today, although these methods are mostly used in multi-threading to send a notification to all threads or all users. So although these are mostly used in multithreading, but these are put in the object class in Java, so that without inheriting the thread class, people can use this. So one of the use of this notify or notify wall, maybe you have noticed that sometimes we got notification from in our app. We use app, right? Many apps in our phone, and sometimes we get notification from the developers. Okay, so that does not mean that the developers send you notification by your name. They give a notification to common, to all, or some selected users, and you get that notification. Okay, so today I want to discuss about thread synchronization. So synchronization is a process. Think about is used to prevent deadlock situation. You know, deadlock situation may happen. You may realize that. Okay. For instance, you are okay. Three friends. Okay, let us do three friends. 1, 2, and 3. So okay, these three friends. You are in a restaurant. Okay. You are in a meeting or you are sitting in a restaurant, and you got some food, and you have a food, some food. Okay, but you got spoon. You have also spoon. Okay, but you got a spoon. You got a spoon, and he got a spoon over here. 3 spoons. But in order to eat this food, you need 2 spoons. We cannot eat this food with a single spoon. Okay. Then, but you have insufficient number of spoons. So apparently you need 6 spoons, right, in order to eat, because according to the food criteria, you need 2 spoons. So you need, if you have 2 spoons, then you can eat this food. If you have 2 spoons, okay. Then if you have 2 spoons, then you can eat it. If you have 2 spoons, then you can eat it. But think about the situation that you have got 4 spoons or 5 spoons, not 6 spoons, right? Think about a situation that you have got, like, for instance, 4 spoons. You don't have these spoons. Okay, I don't want to mess up. Okay, okay. Okay, you got 4 spoons. Then, for instance, this guy is eating, right? He will be able to eat. But until he releases one of the spoons, none of these two people will be able to eat, right? So, and okay, that if there is a situation that he has something to disclose, something secret to disclose, and he says, okay, until I eat some food, I will not disclose that thing, that secret, okay. And if he says that, okay, if he says that, okay, that if he says that, okay, until you give me the spoon, I will not disclose something else. So that means there will be a deadlock situation. It may happen sometimes. In programming situation, it may happen something like this. Like a process or a part of a program is using a data file that will be needed by another process, but until that the first process releases that data file, the second process or second thread, second part of the program will not be able to get that data file, right? Okay, and until the second process releases something, the first person will not be able to do something else. So in programming, if when we have multiple threads, then in doing programs or writing applications in multi-threading system, we need to consider that situation. That is called synchronization. That means you have to set up a way that you can avoid deadlock situation. There are two ways to, the most common way is to avoid the deadlock situation is called synchronization. You have the two modes, you will learn that later, asynchronous mode and synchronous mode. Asynchronous means you don't need to be, you can do it at your any time, in your off time. And synchronous means you need to do online at the right time. Okay. So in Java, in order to synchronize the states, Java is synchronization. Java uses the concept is called and C# also uses the concept synchronizations. Okay, the threads. Okay, I don't have enough slides over here, but I have program I can discuss with this. In Java, there are two ways to synchronize a program: by putting the code in a synchronized block or by using the synchronize statement. Okay, so let's see this in a program. Okay, what is there? This program has error. Color. Okay, I renamed the programs 13. I have to change a lot, sorry. That is messed up. Okay, I don't need public. Okay, got it. Okay, still there is an error called global 18 13. Sorry, my computer is slow. Just too many applications open. I wish I can fix this problem quickly. Maybe got it. Okay, I'm lucky that I got it. So this program, it describes how to use the synchronized keyword, okay, in order to synchronize this call method. This is call me method. This will be synchronized. Okay. So since this course content does not carry enough to discuss this, I'm giving just preliminary idea, okay, initial idea. But I will put this code in my GitHub repository, so then you can get this code and then run this and then read the book and practice this, then you will understand. But at this short time, many of you may not understand this program. Okay, see that this program looks, it is giving me hello Java, hello programmer Java. If I run this again, did you notice that when I ran this program, let me give 3 seconds output. 3000 milliseconds means 3 seconds. When it runs, then look at the output, please. You see that it is waiting hello, then in order to get this, did you notice that it is waiting few seconds in order to get the closing parenthesis? Again, let me run it again. Notice that it will first print hello like this. After that, it will be waiting 3 seconds, then it will get this closing parenthesis. Did you notice? Okay. However, if I do not use this synchronized statement over here, then how about if I run this program? Did you notice the difference in output? So let me, in order to realize this, let me run it again with the synchronized step keyword. Let me run it again and try to understand the difference. This is after hello, it is waiting 3 seconds to get this second part, and this is waiting another 3 seconds. Okay, but when I get rid of the synchronized keyword, and then if I run this, You see the output, it did not wait, right? It did not wait 3 seconds by 3 seconds, but it in order to get button, and I did not get my expected result. So this is the problem of lack of synchronization. Okay. That is, one method did not wait for another method. One process did not wait for another process. So there is another deadlock situation or synchronization situation may happen. That, for instance, let us consider an application of producer and consumer application. A producer produces some items. Let us consider a producer produces only one big item, one item, and some consumers consume those items, that item. Okay. At some point, it may happen that, okay, so then if at some point, okay, if there is a gap, is asynchronous mode between the consumer and the producer, that a producer thinks that, okay, I have some items in stock, until I finish this stocked item, I will not produce that item anymore. In his inventory, he has some item, okay, but that item is not readily available to the consumer directly. That item may be available to another store, in third party, retailer or middleman, broker. Broker does not know that some consumers are waiting or are expecting that, right? But the producer knows that he has a lot of that stuff unsold, right? So the producer is thinking, okay, let me sold those items out, and then I will produce again this item. And at the same time, consumer is thinking, okay, so the item is not available in store or in market. Let me wait some time. When it comes in market, then I will buy that. So in that situation, by just lacking the of synchronization process, right? That both parties are losing. Maybe consumer are losing, and the producer also maybe is losing, right? So that is the lack of just communication gap, right? Because the producer knows that there are some items unsold, but those are readily not available to the consumers. So that may be another situation of asynchronous or deadlock situations. So I will put this program in my GitHub account. I like you to run this program and read the book, and that even you run this program sometime, then go through these lines, and then it's not a big deal. Okay, then we should get some idea. Okay, so the join method here is one of the important methods that is used in order to what is that called? In order to add a thread into the pool. It is called pooling. The process is called pooling. Thread synchronization process. You may when you read this process, and then you will see that it is called pooling. Pooling. This process is called pooling. So when you, so maybe you are used to, so far we discussed sleep method, and at this point maybe we can discuss uh, uh, oh, sorry. The notify and notify wall. Okay, the notify and notify walls that are used to notify. Should I have examples on this? Okay. Okay, that's good that we got an exception that we wanted to discuss. Okay, in order to do thread management, we need to use exception handling, because sometimes it may happen that you want to go to this slide. Sometimes it may happen that you want to start a thread, but that is already killed, or you want to uh, resume a thread, but that is already killed, that is no longer exist. In that case, there may be an exception happens, so we need to do exception handling. We need to use exception handling course in thread multi-threading also. I will show an example, but maybe in we have a few more minutes. Maybe let me go to in C#. Then while we discuss, then we will go to that example. So I did some Google search, and I found that for multi-threading, I don't know. The people says that people opinion that that Java is robust than C# in multi-threading programming. But people who are, how many of you are taking C# lab? Yeah. Okay. So when you develop a game, if you are intended to develop a game, or if you are in gaming method, then you need to give emphasis on multi-threading. Okay. Sometimes you know that you want to create multiple partners. You need to create one or two more partners as a player, right? So that each partner will play as a new thread. Let me go an example. Okay, this thread. Okay, so in this program we have used try, catch, and finally block within these thread statements. Okay, then okay. Okay, before I come here, let me review something quickly. So the multi-threading, managing threads. Not just running a thread. Okay, multi-threading example. Let us go through here. Okay, this is a pretty simple program. Okay, people who are taking C#, okay, keep close attention. So think about without running this program. Okay, so can you please guess what will be output of this program? So then by default our program starts from the main thread. So that first this line will be executed. We expect that. There is no doubt. Okay, and after that, okay, after that, here we are calling the child thread, right? This is my child thread. This is my child thread. Then I expect that this line will be executed. And after that, I expect that if it would be a simple method, I'm going to explain the difference between a method and a thread. Okay, give attention, please. Everybody, please give attention for a few minutes. So there is a difference between a method and a thread. So apparently it seems that this code is within a different method, right? So if it is a method, then at this point my control would go to this method and it will complete the execution of the method, and then control will come back to the my program's next line, right? Next line is here and it will execute this line and then it will execute this line. But for multi-threading, no, it is not that way. It does not work that way. The reason is that we cannot say that which thread will be executing first and which thread will be executing next. We cannot, without controlling, without managing thread, without setting a priority of a thread, we cannot say that. Okay. So notice that my output is I'm sorry, not this one. My program is this, right? Okay, my program is straightforward. Okay, before I running this program, that we thought that this line will be executed first. It's okay, right? This line will be executed first. Yes, okay, that this line executed first. After that, I thought that this line will be the next one, right? But did it come that way? No. If it would be a method, then it would happen that way. But see the difference between a thread and a method. That you don't know until now, since I don't have this is vanilla program. Vanilla is plain, without there is no control in it. I have not set up that which thread will I have not set up any priority for a thread. So I don't know. So by default, all threads are given equal priority. Priorities are set up from 1 to 15. The threads with highest priority will be executed first. The lowest priority will be executed later. So here you see that this line has executed. After that, it has executed this line. But because that it did not call the child thread yet, then it called this line, and after that it called the child thread. Okay, so you remember the sequence? For a minute, try to remember the sequence. I got in main, thank you, press any key, child thread, okay? Okay, so I want to rerun this program and want to check whether it comes same sequence. No, it may not come. It will not come always. Okay, so although this time I got same result, right? All this time I got same result. If I rerun it again and again, sometime I will see that I'm getting a different sequence. I'm trying to get the different sequence. I'm not sure when I will get it. I'm sorry. Maybe program will tell me that. Okay, so there are only 2 threads over here, but yesterday while I was teaching another class, I got that this program was giving different output. Or let me go. Maybe I will get it in another program. If I go to another program, maybe I will. Sometime that is that what I'm going to tell you, that without setting a priority of threads or processes, you cannot say that which thread will be executed first and then later. So that is the main difference between a thread and a method. Calling it fresh vanilla method and the thread. Let me call this one and see what it have. Okay, so main, then thread, then pressure key, almost same thing. Okay, so this program has a use of sleep method. It has use of sleep method. That is, it is waiting sleep for 10 seconds actually. Then let me run it again and please notice the output. It is waiting for 10 seconds, then after 10 seconds, this line will be executed. Okay. So let me go through another program. Okay, destroying threads. Okay. In order to destroy a thread, that I discussed here. In order to destroy a thread, if you think that a thread will no longer be needed, if you confirm that, then we can call the stop method in Java, and in C# it is called abort method. This abort method, when you call an abort method, a thread is called by an abort method. Okay, when a thread calls an abort method, that thread destroys. Destroyed. Okay, so then you cannot call that thread again. So let me run this program. I'm trying to minimize the gaps so that I can show you. Okay. The codes are simple. 5,000 means 5 milliseconds, 5 seconds. Let me show you the output. Okay, so this has use of thread exceptions. Okay, so when you have time, please go through this. But I want to discuss one thing, that thread abort method. So here I have used the thread abort method. So then let us for now forget about the abort method. For instance, I forgot about that abort method. I forgot about this statement. I forgot that this thread was killed. So then after that, if I try to start that thread again, what will happen? Anybody guess what will happen? Anyone can guess what will happen if I run this program again? This program was running without this line, running good. Okay. But if I want to run this, because this line is good here at this position, I'm just copying same statement over here. But before that, for instance, I did not realize that this thread was killed. So then, if I try to run this program, it will create an exception. Did you notice that exception? Okay, so it says unhandled exceptions. That means I do not have try and catch block in this. I have try and catch block in the child thread, but I don't have try and catch block within the main thread. Okay, so this is why it is giving me this exception. So now you understand what is the error for this one, right? Okay, so now can anybody help me to fix this and make this code better? We need to add an exception handling code over here, right? So we need to use try block here. Let me try it. And we will put all of my codes within the try block. And after that, we will see that you cannot use only try, you have to use catch. Okay, so in the catch block, maybe you can give this is a good something that you can get this one. Okay, let us get this. Okay, and also have a finally. Then we can come e dot, what is that called? Track trace control dot sysout. Maybe this one. Okay, let me run this program. Let us see. Okay, thread is running on terminated that cannot be restarted. Okay, my exceptions was not put. Actually, this thread is killed, so it will not be running. But let me go this one. Okay, it's running, but I think we can give different type codes, like for instance wait, and then could see that while we thread is waiting or suspended, we can call it. We could see it. So I have put this code. Okay, one more thing, maybe another word, thread synchronization. Okay, I have also added a few more programs like thread synchronization. Okay, thread synchronization example 1 and thread synchronization example 2. For instance, thread synchronization is needed, especially needed for banking application. Okay. Suppose that some people may try that. Okay, so I have $5,000 or $50,000 in my account. He can send another person next to him, and he can tell that, okay, let us log into my account with 2 different computers parallelly. Okay, and we will try to withdraw money parallelly, right? So that he is giving 5,000 withdrawal, and I am giving 5,000 withdrawal, or transferring to another account. Apparently, it will not happen because the thread synchronization will synchronize every milliseconds. The program is so robust that even people, when you make click on a button, it definitely will be different, right? Even 1 millisecond. So in that case, that is another use of thread. Just press enter to exit. Okay, this is one example, and maybe I have another example here. So I'd like you please download this code and do some practice. These programs are both I have in C# version and Java version. So then if you play with this program and spend some time, then you will be able to understand this thread synchronization concept. So anybody has any question about thread and thread synchronization? And next week is our spring break, and after the spring break we will discuss about, okay, I got these programs here online, some of these programs. So if you do Google search thread synchronization in C#, then you will get some demo programs, and then you can play with these programs, and then you can run these programs. There are a lot of resources online. Okay, here I want to wrap up today, and maybe this is the output of last screen. This is the output from a game, in multi-threaded game. The course modular, the developers who developed this course, sometimes they created this output from their system. So since I don't have control that, I didn't understand what they wanted to mean over here. So this so actually maybe they wanted to show that this priority is normal priority is 5. Priority. In my program, I have programmed some in my GitHub account. You will see you will get my code, and you will see that I have some programs with priority. Anyone has any question that I can discuss before I wrap up? Okay, so next week is the spring break, but I wish you safe and happy break. But if you like, then I want to put some discussion topics so that during your break or after your break you can discuss that. Do you like me to put some discussion topic? Huh?
You guys have some on-topic discussions, maybe like once a week for the rest, just kind of like exercise programming.
Yes. Okay, that's good. So we are almost at the end of this course. I have covered at least about 80%. So we have 20%, and maybe we have 3 more weeks left, right? How many weeks we have left?
5, not counting spring break.
Okay, so after spring break, maybe we will discuss 1 week or one class maybe, about parallel processing. One class I want to discuss about parallel processing. Okay, and then another class I need to do binary search tree. I need 1 week should be fine, and then after that I want to review. Okay, whatever questions you have in your mind, please review and write your question down. Whatever questions so far we discuss in our course. Whatever questions you have lack in understanding, please raise your question, then we will discuss this, okay? And I want to, maybe I will put some discussion, in the discussion topic, some sample questions from test 1 to test 2 and test 3, okay? So that you can review those stuff. Anybody has any comment? Okay, good luck everybody. Thank you. Thank you.